So have you ever really thought about what happens when you spin up a server in the cloud? I mean, it feels like you're getting your very own private computer, right? But you're not. So today we're going to pull back the curtain on the two amazing technologies that make this whole illusion possible: virtualization and containers. Let's dive in.
And this, right here, is the central mystery we're going to solve. You're not actually renting an entire giant piece of hardware from Amazon or Google. So how do they do it? How do they take just one, absolutely massive physical server and slice it up into hundreds of smaller, completely separate servers for all their customers? Figuring this out is the key to understanding, well, pretty much the entire modern cloud.
Okay, but before we jump into the really clever solutions, we first have to understand the problem they were designed to fix. And trust me, it was a huge problem. We're talking about an incredible amount of inefficiency and waste that was happening in data centers all over the world.
Just take a look at this. This shows you exactly how inefficient the old way of doing things was. You'd have this super powerful, expensive physical server just to run one application, and it might only be using, 10 to 15% of its total power? That means a staggering 85% of that machine's potential, not to mention the electricity bill, was just gone, wasted.
I love this analogy because it just hits the nail on the head. Imagine buying a giant 60-seat bus just to drive one single person to work every day. I mean, it's crazy expensive, it's super wasteful, it just makes zero sense. And what's worse, if you needed to run an app that needed a different operating system, you'd have to go out and buy a whole separate bus. Something clearly had to change.
And that brings us to the first huge breakthrough, the first big answer to this problem. It's a technology called virtualization. This was the absolute game changer that finally let us start filling up all those empty seats on the bus.
So what is virtualization? Well, at its core, it's this really clever way of making one physical computer act like it's many different computers all at the same time. It creates these totally separate, digital-only machines. We call them virtual machines, or VMs for short, and they all run on the exact same physical hardware.
Okay, so how does this magic trick actually work? Well, it all starts with a special piece of software called a hypervisor. You can think of the hypervisor as the ultimate landlord for the computer. It takes all the real, physical stuff, the CPU power, the memory, the storage, and it carves it up, right? It allocates these resources out so you can create multiple independent VMs. And here is the really crucial part. Each VM is a complete self-contained computer. You can install Windows on one, a totally different version of Linux on another, all running side by side on the same piece of metal.
The best way to think about this is like an apartment building. The physical server, that's the whole building. The hypervisor we just talked about, that's the landlord, the one who manages everything. And each virtual machine is its own private apartment. It has its own kitchen, its own bathroom, its own front door key. And this is so important. What happens in one apartment stays in that apartment. So if apartment 3A has a massive plumbing leak, it doesn't flood out apartments 4A or 2B. They're totally isolated from each other.
And the benefits of this were just massive. All of a sudden, you could use way more of a server's power, which meant lower costs. This is a huge reason why cloud computing is so affordable today. And for developers, oh man, it gave them incredible flexibility. They could create or just delete entire computers in minutes. And that isolation we just talked about, absolutely critical. If one app crashes inside its VM, it doesn't affect anything else. The whole system stays up.
So virtualization was a total game changer, no doubt, but it wasn't perfect. See, every single VM still needed its own full copy of an operating system, and those are big, they're bulky, and they can be slow to start up. So this led to a new question. Could we get even more lightweight, even more efficient? And the answer to that was the next big evolution: containers.
Now, containers take a totally different approach. Instead of pretending to be a whole virtual computer, a container just packages up one thing, the application itself, along with everything it needs to run. And here is the absolute key difference. A container doesn't have its own operating system. No, it cleverly shares the operating system of the host computer it's running on.
The whole process is so much leaner. You just have one server with one operating system, let's say Linux, then you install what's called a container engine. You probably heard of Docker, that's the most famous one, and that engine runs all your containers. The truly brilliant part is that all of these containers are sharing the very core, the kernel of that single host operating system. And that sharing, that's the secret sauce. That's what makes them so unbelievably lightweight and fast.
Let's go back to our house analogy for a second. If VMs are completely separate apartments, then containers are more like different rooms inside the same house, right? Each room is its own private space. You can decorate it however you want, but they're all sharing the same main plumbing, the same electricity, the same foundation. It's just a much more efficient way to use the shared infrastructure of the house.
And this efficiency leads to some really incredible benefits. We're talking about containers starting up in seconds. Literally seconds, not minutes like a VM. You can cram way more of them onto a single server. And maybe the best part of all, they are perfectly portable. A container that a developer builds on their laptop will run the exact same way in the cloud, which finally solves that ancient developer headache of, well, it worked on my machine.
Okay, so we've got two really powerful but really different ways of doing things. Let's put them side by side, head to head, and make the differences totally clear.
Really, at the highest level, it boils down to this. A virtual machine is a whole virtual computer. A container is just a neat little package for your application. One is virtualizing the hardware, and the other is virtualizing the operating system. That's the core of it.
This table really lays out the trade-offs perfectly. You see, VMs give you that complete, hardcore hardware-level isolation. That's fantastic for security. But what's the cost? They're big. We're talking gigabytes, and they take minutes to start up. On the other hand, containers have lighter isolation, but they are just unbelievably efficient. They're tiny, measured in megabytes, and they start in seconds. So it really all comes down to a choice. Do you need heavy-duty isolation, or do you need lightweight speed?
So why does any of this tech talk actually matter to you? Well, because these two ideas, VMs and containers, they aren't just technical details for nerds. They are the absolute fundamental building blocks of, well, the entire modern internet. Everything from your Netflix stream to your online bank account runs on this stuff.
All right, so to wrap this all up, what are the key things to remember? Virtual machines create fully separate, isolated computers on one machine. They're perfect when you need top-notch security or have to run different operating systems. Containers, on the other hand, just package up your apps to share one OS. They are all about speed and efficiency. So think of it this way. VMs give you isolation, containers give you speed. And together, they are the engine that makes the modern cloud go.
So, I'm going to leave you with a little thought experiment. Based on everything we've just talked about, imagine you have two apps you need to run. One of them only runs on Windows, and the other one only runs on Linux. Which technology would you absolutely have to use to make that happen? The answer to that really shows you the core strength of one of these approaches over the other. Think about it. Thanks for tuning in.